Welcome to TS classes. In this video, we will study about the time response analysis of first order system. Till now we have studied about time response analysis. Now we will study how it is responded to first order system, second order system and rest on. Before going to the first order system, first we have to know that what is a order. Okay, let's start our topic. We know that this is a transfer function model. Input is R of S, output is C of S, transfer is T of S. So T of S is equal to C of S divided by R of S. This is the basic formula. In this formula, if we get this is P by Q, and P is the function of S and Q is also the function of S. Then P of S by Q of S is the transfer function, which is a polynomial. So P of S by Q of S, P of S is known as numerator and Q of S is known as denominator. So what is the order? Order means in denominator it is depend upon S. So in Q of S, the highest value of S is known as order of the system. If Q of S is equal to an into s to the power n plus an minus 1 into s to the power n minus 1 plus similarly an s power 0. That means s power is from n to 0. So the power of s, that is n, which is maximum, is known as order of the system. If n is equal to 0, then it is known as zero order system. And if n is equal to 1, then it is first order system. If n value is equal to 2, then it is second order system. Okay, so the order of the system depend upon the power of S. The highest value of S, that is n, is known as the order of the system. We will discuss it one by one. First we will discuss what is the time response of first order system. This is a transfer function model for first order signal. It means here the transfer function is G is equal to 1 by S of t. Here the power of S is 1, so it is first order system, and we will test it by various types of inputs. First we will study if the input is a step signal. In the previous class we have studied that the input may be of 4 types. First we will study about what is a unit step input. In the unit step input, we know that here input is given, so R of t is equal to 1. Here the gain signal is, that means here G is equal to 1 by S into t, and feedback is H is here 1. We know that in a transfer function, the transfer function t is equal to G divided by 1 plus G into H, because it is a negative feedback. If it is a positive feedback, then it is minus will be here. So what is the value of transfer function here? Here the transfer function value is equal to G is 1 by St. So 1 by St divided by 1 plus 1 by St into 1. So by simplifying this, I will get it that 1 divided by St plus 1. This is the transfer function, and the input is depend upon time, so input is equal to 1. The Laplace transformation of the input, that is Laplace transformation of R of t, is equal to R of S is equal to 1 by S is here. R of S is equal to 1 by S. We have to find what is the output of the transfer function, that is what is C of t. We have getting here C of S. By getting the inverse Laplace transformation, we can get C of t here. So first we will find what is C of S. So we know the formula, C of S by R of S is equal to the transfer function, where here the transfer function is 1 by St plus 1. 1 divided by St plus 1, and we know that R of S is equal to 1 by S here. That implies C of S is equal to R of s into T of s, which is equal to 1 by s into 1 by st plus 1. If you simplify this 1 by s into 1 by st plus 1, we can get 1 by s minus 1 by s plus 1 by t. This is the C of s. If we get C of t, which is equal to Laplace inverse of C of s, which is equal to Laplace inverse of 1 by s minus 1 by s plus 1 by t. That implies Laplace inverse of 1 by s minus Laplace inverse of 1 by s plus 1 by t, which is equal to, this is 1, Laplace inverse of 1 by s is equal to 1 minus Laplace inverse of 1 by s plus 1 by s plus 1 by t is equal to e to the power of minus of t by capital T. This is the C of t. That means we get the C of t is equal to 1 minus e to the power minus t by capital T, which is purely depend upon the time. So here the output is time domain. In this equation, we are getting some error, that is the error analysis. If we get the error part, that is E of t is equal to, error is what is the difference between the input and output. The input is R of t is equal to 1, R of t minus C of t is the error. Input is 1 and output is 1 minus e to the power of minus t by t. That implies the error part is e to the power of minus t by t. This is the error of a first order transfer function when the input is step input. In today's class, we have studied about the time response analysis of a first order system when the input is step function. In the next class, we will study about the time response of a first order system when the input is ramp input and impulse input. Thank you.